This is OpenNMS 101 again, Module 11, Part B, completing data collection configuration. Part A of this module completed the skeletal configuration of data collection/tutorial.xml and data collection-config.xml. This video will complete the configuration in those files and make necessary adjustments to collectd-configuration.xml based on the RRD configuration in data collection-config.xml. Data collection will be demonstrated. To create a data source from which to collect metrics, this video will use SNMP extensions. SNMP extensions were covered in Module 8, Service Assurance. A shell script, user local bin, tutorial collector.sh will be created that generates a random number. A tutorial collector extension will be added to snmpd.conf, and the snmpd.service will be restarted. Change directories to user local bin. Edit the file, tutorial collector.sh. Add the bash shell and random echo lines as shown. Save and close the file. Change the file permissions so that the owner has read, write, and execute permissions, while all others have read and execute permissions. Change the file's ownership to OpenNMS. Execute the file a number of times to get an idea of how it works. Change to the etc snmp directory and edit snmpd.conf. Scroll to the bottom of the file and add the tutorial collector extension and tie it to the script just created as shown. Save and close the file. Restart the snmpd service. Test the snmp extension using snmp walk against ns extend output to table. Add a few more echo random lines to tutorial collector.sh and retest with snmp walk. Note the indices on the tutorial collector output. Reset tutorial collector.sh to a single random line of output and retest using snmp walk. Use the -on argument with snmp walk. The OID will help create the MIB object line in data collection/tutorial.xml. Run snmp walk against ns extend output to table. Tutorial monitor was created in the service assurance module. It has no bearing on this module. The tutorial collector output is a random number as a string. Edit tutorial collector.sh and add 2 more lines of output. Save and close the file. Rerun snmp walk ns extend output to table. The added tutorial collector lines include different index numbers for each line of output. The indexes will be used in the MIB object configuration. Edit tutorial collector.sh and remove the extra output lines. Save and close the file. Rerun snmp walk ns extend output to table. The result should be similar to the first run, a single line of output for tutorial collector. Finally, run snmp walk ns extend output to table using the -on argument to produce a numeric OID on output. Note the ASCII representation of tutorial collector in the output, followed by an index. A correction. In the last segment, the term index has been used to identify the last digit in the OID. The correct term is instance. A piece of cheese here, un pedazo de queso ahí, it's all the same to the mouse. As this tutorial is using an instance to define the MIB object element, it will help to find a MIB object in use that includes an instance, particularly an instance equal 1, in the data collection XML files. cd data collection, run the grep shown, searching for instance equal 1. As luck would have it, netsnmp.xml has such an entry. It's part of the load average 1 MIB object. Edit netsnmp.xml and search for load average. This is a perfect template for the tutorial collector script. It's time to define the tutorial collector MIB object. Begin in the data collection directory. Edit tutorial.xml. Remember to use load average 1 as a template. Get rid of the comment placeholder. Begin the MIB object definition with the OID of tutorial collector. To get that, run snmp walk ns extend output to table with the -on option and copy and paste the OID for tutorial collector. Do not copy the .1 instance at the end. After pasting the OID, add the instance value of 1. Call this metric tutorial1 and add that as the alias value. Finally, add the type integer. Save and close the file. The MIB object in tutorial.xml is defined. There are a number of RRD components in OpenNMS, including the RRD repository, the RRD element in the various data collection configuration elements, and the tools that come with RRD, particularly rrdtool. This is the rrdtool homepage. rrdtool is the work of Tobias Oettinger and others. RRD stands for Round Robin Database. With RRD, time series data, almost any kind of data, is stored in a circular buffer of a data store. OpenNMS retrieves data and needs a way to store it. Data is stored in an RRD repository. SNMP and a number of other collectors default to using /op/OpenNMS/share/rrd/SNMP as the starting point for the repository. The actual data is stored in RRD files. Focusing on SNMP, these are the RRD-related elements in datacollection-config.xml. The RRD repository is defined as just noted. The RRD element will be covered later. This is a listing of directories and files in the RRD repository. By default, OpenNMS stores data in the RRD repository by node ID. Currently, there is only one node collecting data, the local host, number 1. There are a number of directories and files underneath the node ID directory. How does OpenNMS determine where to store a particular metric? Using datacollection/mib2.xml, the TCP cur estab is a non-interface metric with an instance value of 0. This indicates a node-level metric. The RRD file will be stored in the node ID directory. And here it is. IFHC in octets and IFHC out octets are interface metrics. Interface metrics are stored in a node ID subdirectory with the name interface name -interface hardware address. Use the command IPA to determine the interface names and addresses. Ignore the loopback interface. The second interface has the name ENS160 and the hardware address 00:0C:29:71:EE:67. OpenNMS strips the hardware address of the colons for naming purposes. The directory name used by OpenNMS to store this interface's metrics is ENS160-00C:29:71:EE:67. Here is the interface's subdirectory. And these are the metric files in the interface's subdirectory. The last example is for HR storage size, HR storage used, and HR storage alloc units. The IF type is all, and the instance is HR storage index. There is a resource type named HR storage index. The top directory for these metrics is node ID/HR storage index. Metric storage is further divided into subdirectories relative to node ID/storage index. The resource type defines the storage strategy as sibling column storage strategy. Metrics are stored as siblings. Metrics are stored under parental directories named by the sibling column name. In this case, the sibling column name is the value of the HR storage description object with some modifications. With the results of SNMP walk localhost HR storage descript in the bottom frame, apply the sibling column storage strategy modifications to each HR storage descript instance. OpenNMS first applies a built-in sibling column storage strategy to all instances. Change / to dash. Apply that modification. The mods are applied in the lower frame. The next modification is to change a value of dash and only dash to _root_fs. Apply that modification. The mods are applied in the lower frame. The next modification removes all dashes at the beginning of a value. Apply that modification. The mods are applied in the lower frame. The next mod removes all spaces from the value. Apply that modification. The mods are applied in the lower frame. The final mod does not apply in this case. These are the names used to group sibling metrics. A listing of the node ID/H storage index bears this out. If you need to, pause the video. Within each subdirectory are the RRD metric storage files. Return to the RRD element within datacollection-config.xml. Think of RRD as consuming the collected SNMP data at a specific rate. The rate is the step value, which is in seconds, in this case 300 seconds. If the collector SNMP service interval is higher than 300 seconds, RRD will have to crunch the data at its step rate. For example, average it out. If the collector SNMP service interval is lower than 300 seconds, RRD will not consume data and log the value as NAN, not a number. It is best to have the service collection interval match the RRD step value, as it does in OpenNMS. Remember, the interval is in thousandths of a second. Break down the first RRA line as follows. One input is required for one data point. One input is collected every 300 seconds. That means that 288 data points are collected each day. RRD will store 2016 of these data points, which translates to 7 days of storage. Average 1 data is kept for 7 days. Break down the second RRA line as follows. 12 inputs are required for one data point. One input is collected every 300 seconds. That means that it takes 60 minutes to collect a data point. That means that 24 data points are collected each day. RRD will store 1,488 of these data points, which translates to 62 days of storage. Average 2 data is kept for 2 months. Break down the third RRA line as follows. 288 inputs are required for one data point. One input is collected every 300 seconds. That means it takes 24 hours to collect a data point. That means that one data point is collected each day. RRD will store 366 of these data points, which translates to 1 year of storage. Average 3 data is kept for 1 year. Max data is configured as average 3. Max data is kept for 1 year. Min is configured as average 3. Min data is kept for 1 year. Change the tutorial SNMP collection in datacollection-config.xml. Change the RRD step to 60 seconds. Continue to provide 7 days of average 1 data points by changing the row's value to 10,080. The number of inputs required to get an hourly average is now 60. The third average, max and min, are based on data points collected daily. That total is 1440. This completes the tutorial SNMP collection configuration in datacollection-config.xml. Modify the tutorial package's SNMP service interval to match the RRD step in the tutorial SNMP collection. Set the value to 60,000. This completes the tutorial collection configuration process. In data collection/tutorial.xml, the tutorial data collection group included an alias, tutorial1, associated with the output of the SNMP tutorial collector extension. In datacollection-config.xml, a tutorial SNMP collection was built to include the tutorial data collection group. And finally, in collectd-configuration.xml, a tutorial package was created that included the tutorial SNMP collection as an SNMP service. Because a service was added to collectd-configuration.xml, OpenNMS needs to restart. Restart OpenNMS with system control restart OpenNMS.service. After a bit of time, recheck the status of OpenNMS using OpenNMS-v status. All OpenNMS services are running. Recalling that tutorial1 is the name of the new alias, verify that tutorial1.rrd exists in the rrd repository node=1 directory. Check to see if data is collecting using rrdtool. The command shown, rrdtool fetch rrd-filename average, fetches average data from the rrd file. There are already 2 data points. The time of the first data point is June 15, 2024 at 10:35 a.m. The time of the second data point is June 15, 2024 at 10:36 a.m. Data is being collected every minute as configured. Coming up, Module 11, Part C, Graphing SNMP Data.